You know those math problems from school, right? The ones about trains and cars? They always gave me a headache. Well, today, we're gonna unlock this one simple secret that makes even the toughest motion problems, believe it or not, super easy to solve. So let's dive in.
Yep, those are the ones I'm talking about. You've got 2, sometimes even 3 things all moving at the same time. It's like they were specifically designed to be confusing, right? Just a total headache. So why are they so tricky? It's a great question. And you know, the answer is kind of surprising. It's not usually the math that's hard. Nope, it's all about how we look at the problem. We're trying to track way too many moving parts at once, and that's the exact thing we are going to fix right now.
All right, before we jump into the big secret, let's do a super quick review of the basics. There's one simple formula that is literally the engine behind every single one of these problems.
And there it is, distance equals speed times time. That's it. How far something goes is just how fast it was going multiplied by how long it was going for. Every single one of these complicated problems, they're all built on this one simple, solid idea. Okay, so we've got our foundation. Now, for the secret sauce. This is the little mental trick that is going to completely change how you look at these problems. It's the key that unlocks the answer, every single time. So here's the big idea. Instead of trying to keep track of 2 different cars with 2 different speeds, what if we only tracked one thing? What if we just tracked the space between them? That one little change in perspective takes a really complicated problem and makes it incredibly simple. You'll see that basically all of these problems break down into one of 2 stories. That's it, just 2. Either things are moving towards each other, or one thing is chasing the other. They might look different on the surface, but trust me, we're gonna solve them using the exact same secret. All right, let's put this to the test. Let's start with our first scenario, the head-on collision. Well, not a collision, the head-on approach. So picture this, 2 things. They're 100 meters apart, and they're moving straight towards each other. One's going 15 meters a minute, the other one's going 10. And the classic question is, when are they gonna meet? So if we want to figure out how quickly that 100-meter gap is disappearing, we just have to look at what they're doing together. I mean, every minute, one of them covers 15 meters of that gap, and the other one covers 10. So the distance between them is actually shrinking by their combined speed. And we have a name for that. We call it closing speed. It's literally just the sum of their speeds. So in our example, the closing speed is 15 plus 10, which is 25 meters per minute. And just like that, we've turned a problem about 2 cars into a much simpler problem about one single gap. And now, look at this. The solution becomes so simple. The time it takes for them to meet is just the original distance, that's the s, divided by their new closing speed. So for us, that's 100 meters divided by 25 meters per minute, which gives us 4 minutes. Boom, problem solved. Easy, right? Okay, so that was scenario 1. Now let's look at our second story, the chase. This time, both things are moving in the same direction, but one is faster and it's trying to catch up to the slower one. So how does our little secret work here?
Well, this time, we don't care about their combined speed. What we care about is the difference between their speeds. Think about it. If one car is going 80 kilometers an hour and the car it's chasing is going 60, the faster car is only gaining on the slower one by 20 kilometers every hour. That's the key.
And yep, you guessed it, we've got a name for this too. Catch-up speed. It's just the difference between their 2 speeds, and honestly, it's the only number that really matters here. It tells you the real speed at which that gap between them is shrinking. And just like before, the formula becomes super simple again. The time it takes to catch up is just the starting distance between them divided by this new catch-up speed. See? It's the exact same logic, we just calculate the speed a little differently. This right here, this is the real heart of the mental shortcut. You can literally just pretend the slower object isn't moving at all. It's just stationary, and the chaser is approaching it at that catch-up speed. Thinking about it this way completely simplifies how you picture the whole thing in your head. All right, so now we have our new toolkit. We have our 2 scenarios. Let's put it to the test on a problem that, I gotta say, looks way more complicated at first. Okay, here we go. The challenge problem. You've got a circular racetrack, it's 14 kilometers long, 2 cars start at the same time, going in the same direction. We know the first car is going 80 kilometers per hour, and we know that it laps the second car in 40 minutes. So the big question is, how fast is that second car going?
That whole circular track thing, it's designed to make this feel way harder.
This looks tough, right? But just take a second. Which of our two stories is this? Is it a head-on problem or is it a chase problem? You got it. It's a chase. Think about it. For the faster car to lap the slower car, what does it have to do? It has to make up one full lap of distance. So this is just a chase problem where the distance to catch up is the length of the track, 14 kilometers. Okay, so let's just plug the numbers into our chase formula. Time equals distance divided by catch-up speed, right? The time, well, it's 40 minutes, which is 2/3 of an hour. The distance it needs to cover is 1 lap, so that's 14 kilometers. And the catch-up speed is the fast car speed, 80, minus the slow car speed, which we don't know, so we'll just call it x. So you get this simple equation, 2/3 equals 14 divided by 80 minus x. You do a tiny bit of algebra, and you find that x is 59 kilometers per hour. And just like that, that really tricky-looking racetrack problem just fell apart when we used our simple framework.
So what's the big takeaway here? Is this just about, passing a math test? Nah, it's bigger than that.
The real lesson is about this simple process. It's about realizing that the problem wasn't actually complicated because of the math. It was complicated because of how we were looking at it. By changing our point of view and focusing on that relative speed, we turned a really confusing situation with two moving parts into something super simple that we could solve in a snap.
And that's a lesson that goes way beyond math class. It's such a powerful reminder that sometimes the hardest problems don't need a more complicated solution, they just need a different point of view. It kind of makes you wonder, doesn't it? What other complicated problems in your life could be made simple just by changing how you look at them? Thanks for tuning in.